Okay, so as you look at these pictures, I want you to classify the triangle by its sides and its angles. So you're going to decide, is it an equilateral, isosceles, or scalene, and then determine is it an acute, right, or obtuse. So you want to name each one. So go ahead and pause the video, look at it, determine it, and now I'll answer them. So our first one is an acute isosceles. You could say acute and isosceles or isosceles acute, whatever. Middle one is an acute scalene. I almost said pinballs. The billiard balls are acute equilateral. The piece of bread, isosceles right. And last one is a scalene obtuse. So if you ever have questions as we're going through this, make sure you write them down so you can ask your questions in our live classroom. So if there was anything that was confusing on this as to why, go ahead and write that down and make sure you ask it tomorrow. Okay, so from the previous lesson, when we were looking at lots of triangle things, I never really told you this, but I was hoping that you could observe it. So we looked at congruent triangles and we're always seeing how congruent triangles have the same angle measures, the same side length measures. But if you notice, every time that a triangle's angles sum up to 180 degrees, no matter how the triangle looks, no matter if it's acute, right, or obtuse, all of the angles added together will be 180 degrees, which I'll give you a hint as to why in the coming slides. So here are just some examples. No matter what, again, obtuse, right, acute, another one, all the angles will add to 180 degrees, which is really useful to know because it helps us determine other polygons' angles, and we'll take a look at that in the future. So this is just a random fact that is good to know. So, this is a classification of quadrilateral. So polygons are like the overall term, and then quadrilaterals. So the basic thing of quadrilateral, if you just think of the word quad, it just means that it has 4 sides. So all these below are types of quadrilaterals. So if we jump over to the kite has these 2 sides congruent, these 2 sides congruent, and these 2 angles congruent. So make sure that if I were to give you a shape, you could identify it as a kite, or maybe use this idea of this side equaling this side if I were to ask you to find the missing side lengths maybe. Next is a trapezoid. Which all that's required for it to be a trapezoid is there's just one pair of parallel sides. Now remember, parallel means that 2 lines never intersect. So this would be my pair of parallel lines. So I just need one pair of them. That classifies a trapezoid. Jumping over to parallelogram. So different from a trapezoid, and this one has 1, but parallelogram has 2 pairs. So these 2 would be parallel, and then these 2. So that's how we get the 2 pairs. The rest below, rhombus, rectangle, and square, are types of parallelograms because, as you can see, they each have their own pairs, 2 pairs of parallel lines. So a rectangle, so first it has the 2 pairs of parallel lines, and then it has 4 90-degree angles, which you can see there. A square has those 4 90-degree angles, and 4 for congruent sides. And then lastly, rhombus, the only important thing is for congruent sides, but notice it does not have 90-degree angles, because that would then make it a square. So, on our next slide, we're going to look at some true and false statements using these definitions. So now would be a great time to pause the video and to try to determine, are these statements true or false? So once I reset, maybe it would be a good time to pause. So if you pause, and then I will now answer it. First one's false, true, 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 false, false. If there are ones that you disagree with, I think that would be great for us to discuss in our online class. So if there's some that you're like, I don't agree with that, or I thought something differently, let's definitely talk about that tomorrow. So, a regular polygon is a shape that has all sides congruent and all angles congruent. So, I know that you've heard these shape names before, but just to review, just in case. So, we've already discussed equilateral triangle. Then we have square, a regular pentagon. So, a pentagon, notice, has 5 sides, penta. Hexagon, 6 sides, 7 sides, etc., etc. So what makes them regular, though, is that all of the sides are congruent. So for example, all these sides should be congruent, and all the angles inside should also be congruent. That would make it called regular. So make sure you know these names, and just the idea that if it's a regular polygon, then the angles and the sides are all congruent to each other. So there's a cool fact about interior angles that we will use this to kind of discover that. So interior angles are the angles inside a shape. So for example, if I have a rectangle, my interior angles would be those 4 angles. Remember, an angle is formed by 2 rays, so I want to not just pick a random space in the rectangle. It has to be where the lines are meeting, or the segments are meeting. So, because a triangle is 180 degrees, we're going to use that fact, but a way to kind of double show you why it's 180 degrees is if we think of a quadrilateral that has 4, like a rectangle. In this case, there's 4 90-degree angles, right? Which 90 plus 90 plus 90 plus 90, or 4 times 90, would be 360 degrees, right? But if I try to draw a triangle, or multiple triangles in the rectangle, we can see that I can split the rectangle up into 2 triangles. And since 2 triangles would be 180 times 2, that also shows us why it's 360. So there's multiple proofs kind of going on here. So we're going to use this idea of how many triangles can we fit into the polygon, and use that to tell us how much is the sum of the interior angles. So again, the rectangle, we have 180 degrees, 180 degrees. So that's why 360 degrees makes up a quadrilateral. Okay, let's move on to the pentagon. So our goal is to try to draw triangles in here. So I'm just going to pick a point and try to go to all of the other ones. If I go here, that would make a triangle. But if I draw a line here, there's a triangle in here. So this time I have 3 triangles in the pentagon. Since each triangle is 180 degrees, 3 times 180 is 540. So pentagons will have a sum of 540 of all of the interior angles. So this angle plus this, plus this, plus this, plus this will be 540 degrees. So I want you to pause the video and try to fill out the rest. This last one is, let's say we didn't know the number of sides, but can you find a pattern from the ones that you did before to determine, can I find the sum of the interior angles no matter how many sides I have? So go ahead and pause the video, fill this out, especially think of this one and what patterns you're noticing. But now I'll complete it. Hopefully you did pause it and tried it on your own. So you could have used these to help you. So for the hexagon, we have 4 triangles, which then 4 times 180 is 720. Octagon, there's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So 6 times 180 is 1080 degrees. So an octagon will have a sum of 1080 degrees of its interior angles. And continuing on, decagon had 8 triangles, which maybe you wanted to draw it, but maybe you noticed the pattern. 10 triangles in a dodecagon. So, the goal was to try to figure out, do we see some relationship going on here? And if you compare n, which is the number of sides of the polygon, to the number of triangles formed, if you notice there's always a difference of 2. So we can always fit 2 less than the number of sides of how many triangles there are in there. So we can write an expression of n minus 2 to show the number of triangles in a polygon, which, once we had the number of triangles, we just multiplied it by 180. So if I show that as an expression, that would be how I could find any kind of polygon. As long as I knew the number of sides, I could figure out what the sum of the interior angles would be. So this is useful to know because basically if you know the number of sides, you can know what the sum of the interior angles is. Also, if you know if it's regular, you can determine how much one angle measure would be. So for example, if we had a regular pentagon, so I know the sum is 540, and I know there's 5 angles, and since it's regular, all angles would be equivalent. So if I just divide by how many angles are in there, I would know that each one would be 108 degrees. So you could try to find how much would one angle be for an octagon. In a regular octagon, you can do that now, and I'll answer it. So an octagon has a total of 1080 degrees, but there's 8 angles in there. So if I divide 1080 by 8, I can get what one angle is, which is 135 degrees. So this is just a useful fact to know, to find missing side lengths, and it also just gives you characterization of different types of polygons. So last thing we'll look at, this talks about interior angles, let's talk about exterior angles. So an exterior angle is an angle that lies outside of the polygon, hence the name exterior. So I would want you to think, if you were here, I would ask you, what do you think this angle measure would be? I would want you to try to determine it based on things you already know. So if you want to give that a shot, hit the pause button. But one way that we can use this is, okay, I know that a triangle has 180 degrees. So if I subtracted 70 and 50, I would get 60 degrees. So that one has to be 60. If I want the sum to be 180 of the triangle, which it has to be. Which then, from back in the day, we know that these would be supplementary, right? Because they form a straight line together. So 180 minus 60 would be 120. Now, you might have noticed something, but if not, we'll do one more, but we're trying to find, is there an easier way to maybe do this than having to think the sum of triangles 180, blah, 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 and keep going. So, again, I know that this will be all 180, so if I subtracted those added together, it would be 105, so that would have to be 75 degrees. Which, using supplementary angles then, 180 minus 75 is 105. If you saw it yet, then great. If not, there you go. So if you notice, we get 105, which, where did that 105 come from? It came from these two added together. So exterior angles can easily just be the sum of the interior angles that are opposite of it, which we kind of proved just based on the sum of triangles, angles being 180 and using supplementary angles. So that's kind of a quick way to do it, is that instead of doing the whole 180 thing, blah, blah, I can just say, okay, these are the opposite interior angles, so those added together will be that exterior angle. So you can go ahead and try the rest. This one requires you to use that idea, but just in a different way. So go ahead and pause and try those on your own. So this one, I know that this plus this would be 110, right? Because these are the opposite interior angles, and that's supposed to equal the exterior angle. So if I just subtract those, that tells me that that angle is 30. This angle 86, just adding those two. And last one, 65, because this plus this should be 150. So that's it for 7.6. I'll put the homework assignment on there. One homework assignment though is to show me that you watched the video, took notes, so submit some document that shows me that. Tomorrow is our online class, so be prepared with any questions you have, but most of it will just be practice to make sure that you can practice and ask any questions that you have based on that. But I hope things are going well so far. If something has been confusing or you think could run smoothly, like better, just let me know. We'll figure this out. See you guys.